All right, so today we're going to look at physical and chemical changes that can happen with matter. So we'll look at the differences between them and kind of some key terms to look out for. So matter can undergo changes. Of course, matter doesn't always stay exactly the same forever and ever. So they can be classified as either a chemical change or a physical change, okay? In general, the way to think about these, physical changes might be changing the appearance of something, but the particle stays the same. Okay, so for example, I can have water and change the form that water is in, but it's still made up of H2O. A chemical change is anytime you are making a new type of matter. Okay, so physical change. So when we're talking about a physical change, right, there is no new substance that is being formed. So this might be a change in appearance, but you're not changing the actual substance. Okay, so here are some examples or some terms to kind of look out for. So anytime you see the term dissolving, okay, when we dissolve something, you're not actually changing the material. All you're doing is really making a mixture, right? So if I have salt and I dissolve it in water, I still have salt and I still have water. It's just that those two things are now mixed together, right? I can have sugar dissolved in water or whatever it is. If you see the term dissolved, that means that all you're doing is you're putting them together to make a mixture. Another thing to look out for are, is this change that matter is undergoing simply a change in state? So things like melting, freezing, sublimation, condensation, evaporation, all those things that we looked at when we looked at changing of the states, right, going from solid to liquid or liquid to gas, etc., those are just simply changing the appearance of that matter. You're not changing what it's made up of. So when I have water in solid form, it's really still water when it is liquid water. If I were to make it evaporate water and have it now become a gas, it is still just water. So another example of a physical change is if you're changing the shape. So change of shape. So for example, if I have a piece of chalk and I crush it into a powder, or I have a sugar cube that I crush into powdered sugar, or I have an elastic band and I'm going to stretch it. Those are all examples of changing the shape, but you're not changing the actual substance. Okay, so even something such as, I take a piece of paper and I'm going to rip it in half. So even though I'm changing it into two pieces instead of one piece, it's still made up of paper, right? I didn't change what the substance actually is. So all the examples of physical change means that even though you're changing the appearance or the form that that matter is in, it is still the same substance. So the particles of what that matter is made up of is still the same. Okay, now physical changes can normally be reversed. Okay, but keep that in mind, that is not all types of physical changes, right? So for example, if I have an ice cube and I melt it into liquid, right, like a liquid water, so if I go from solid to liquid, I can reverse that by putting it back in the freezer, right? But if I have a piece of paper and I rip it in half, that's not easily reversed. Okay, so don't always go by this. To be honest, I don't even really like the fact that your textbook or a lot of different places say this, because if I were to, cut something in 1,000 little pieces, that's very hard to reverse, but it's still made up of paper, right? I didn't change what it actually is. I'm just simply cutting it in half, right? Or if I chop down, let's say I have a piece of wood, I chop my wood in half, it's still made up of wood, right? I didn't change what it is. So they can normally be reversed, but again, take that into consideration that it's not always true. Sometimes you can have something that is hard to reverse, but it is still just a physical change. What I want you to think of is, are we making something new? Is this a new particle? Okay, so a chemical change is where you are making at least one new substance. So that means we're going from water to, let's say, hydrochloric acid, like something completely different. So you are making at least one new thing. So what we're going to go through is like, how can you identify when something new is made? Like, what are the things to look out for? But that's really the definition of a chemical change, is you're making something new. So these are just some examples. So a piece of paper is burned, okay? Anytime you see the term burning or burned, this is for sure a chemical change. So you are taking that piece of paper and you are basically burning it and you're incinerating it. So it is definitely, you are making something new, right? It's no longer going to be paper at the end of it. It's going to be essentially ash, right? So be careful though, when we say burning, that is not the same as warming, okay? So if I want to warm up an ice cube, that is different than burning, I don't know, burning a piece of chicken or something, okay? So the term burning means you're literally like, you are heating it up to very, very high temperatures, you're incinerating it. Warming up does not necessarily mean a chemical change, okay? It just means you're increasing the temperature by a little bit, right? Maybe for change of state. But the term burning, for sure, is a chemical change. A tin can is rusting, okay? Rusting is another form of a chemical change. Rusting or tarnish, okay? Rust and tarnish can be used interchangeably. Essentially what that means, usually it's a metal, but something is reacting with oxygen in the air and it is making something new. Like the rust that it is making, the tarnish that is being made is the new substance. Okay, so how are we going to know how do we know if something new is made? I'm going to let you go through some examples with you. But normally, a chemical change cannot be reversed, okay? So same thing as with physical change. Is this true in every single case? No. It's more like a general statement. There are some chemical changes that can be reversed. So this is not your go-to for evidence, okay? So let's talk about what can we use for evidence. So evidence for physical change, usually you have one or two things happening. Change of state or change of shape. Okay, those are the two most common things. Usually the color also stays the same. So whether I have, let's say I have liquid water, gas water, well, this is colorless, but they're all colorless really, but normally it stays the same. So think of changing the shape of like a rubber band, right? So if I have a rubber band and I stretch it, it's still rubber, right? I'm not changing what it is. Or if I take a sugar cube and I crush it into smaller particles, it's still sugar cubes, right? So in general, those are things to look out for. Now, what are some evidences for a chemical change? So a chemical change, you have one of 5 things happening, but to be honest, the first 4 are really your main things to look for. So first off, a new color may appear. Now, I have 4 things listed here. Sometimes chemical changes can have one of them happening. Oops, oh my goodness, I don't know what I did. Let me get out of here. What did I do? I don't even know if this is still recording. Oh, it is still recording. Oh my goodness. Okay, people. Let me pause this video so we could get this fixed. Okay, we're back. Whew, sorry about that. It's like comic relief in the middle of that there. Okay, so we have, even though we have, like I was mentioning before, we have a bunch of different evidences. So you can have one of them happening. Sometimes you can have two happening at the same time. Sometimes you can have three things happening at the same time. Really, these are just things to look out for. So as long as if you have one of these things, and it also has to make sense though. So it has to also mean that you're making something new, okay? So a color change appears, new color. Heat or light is given off. So this is just in general, this is like energy. Energy is given off. Bubbles of a gas are formed. Okay, and this is new gas. Okay, I'm going to clarify each of these also. A solid material called a precipitate is formed from two liquids mixing. And of course, the change is difficult to reverse. Okay, so let's go through each of these. So a new color appears. Be careful with this one. So new colors can sometimes happen when you have a mixture. So for example, if I had, blue paint and red paint, and I mix them together, I think that gives me purple. Anyway. Or blue and yellow make green, right? So I can have a mixture that gives me a new color. This is not a chemical change. This is a physical change. It's still paint. All I'm doing is I'm making a mixture of it, right? Let's say I have, it could be anything, food coloring. Like think of anything that has a color. If you mix a bunch of colors together, you can change the color of something, but it doesn't mean necessarily that you're making something new, okay? Normally, a new color happens with something else, okay? So you might have a new color and heat or light is given off. You might have a new color and gas bubbles or a precipitate, okay? So just be mindful. So all of these, no matter what, if you're saying it's a chemical change, that means you are making something new. So heat or light given off, think of, anything that's actually on fire, right? So like lighting a match, like the lit match is actually a chemical change, okay? Light being given off can be, of course, the same thing. Or you can think of like fireworks, anytime where you have heat or light, or really any form of energy, but these are the two most common forms. So bubbles of gas, so be careful with this one. So we're not talking about change of state here. So we're not talking about a liquid becoming a gas. Okay, this is a new gas that is formed that is not expected. So we're not heating something up and making something boil or evaporate, right? So what we're doing here, let's say you mix a solid and a liquid together and it starts fizzing. Okay, so we're not referring to evaporation here. So if we're boiling a pot of water, that is not a chemical change, right? And of course, a solid material, which we call a precipitate, this is where you mix two liquids together and you form a brand new solid, okay? So the last one here, change is difficult to reverse. So this reasoning, this evidence, so remember these are all pieces of evidence. The evidence that it is difficult to reverse is actually a valid reason for a few things. Okay, so we already mentioned rusting or tarnishing. Okay, so Rusting and tarnishing also has a color change, okay, but it's a color change that is difficult to reverse.